So, to start off with ferrets and a pumpkin.
Yeah, so there are two.
So, there's two?
Yeah, it starts off with two albino ferrets.
Okay, so there are, in the beginning,
What is two ferrets?
in the beginning there were two ferrets.
Sounds very biblical.
Okay?
Yeah.
In the beginning, what is the time?
In the beginning of time is 0.
Okay, so we might think about this as t is 0. What else do I know about? Okay, so that's over here, right? Not in the beginning, but in a year.
Yeah.
There's what?
There are 8 ferrets.
There are 8 ferrets. Okay. What time is that?
Most say T1.
Okay, that seems legit. So now we've specified that we're entering time values in years. You guys see that?
Yeah.
Okay. What other things do I know about?
Nope, that's it.
Yeah, that's pretty much it. So I think I need a tool for this. You guys remember what the tool was for populations?
Negative E. Negative
A.
P of t is
P naught times E to the
KT.
RT.
sure RT, KT, whatever. So traditionally this is a K if you're talking about money and an R if you're talking about populations. I'll follow tradition for right now. Okay, so what I need to do is I think that means I know something else.
T equals 2 times 0.
T equals 2?
P of T equals 2.
P of T equals 2.
How about P of 0 is 2?
P of 0 is 2.
You guys sit with me on that?
Yeah.
Oh, and P of 0 has a special name in that formula.
So 2 is the P of.
Yeah, so P sub 0 is that 2.
It's the initial population.
Yeah, that's the initial population. You guys see that?
Yeah.
Okay, and then over here, what do I know about? There are 8 ferrets in a year. So,
8. E to 8.
so P of 1 is 8. You guys see that?
Yeah.
On the other hand, what's P of 1?
R? No.
Yeah. P of 1 is, on the other hand, 2e to the r times t, but t is 1, so this is really just e to the r, right?
Nice.
You guys all see that?
Where are you getting to? Oh, I just get
Okay, and then this is a crucial step about population models. You have on the one hand, they told me what P of 1 was, and then on the other hand, the model told me what P of 1 was. So these two values should be the same, right?
Yeah. So E has to be 1.
So,
I mean 4.
so 8 is 2e to the r,
So 4.
or alternatively, you could think the thing that Levi just blurted out,
Almost.
which was e is 4, right? Which is not actually a bad thought. What happened was your population quadrupled in a year, right? So instead of the e to the r part of this, you could put a 4 there. You guys see that? Like that would be kind of clever. You don't have to think that way, you can just do this. So if you didn't understand anything I just said, just take this and solve it. So multiply by half, you get 4 is e to the r, right? And then what?
Natural log both sides.
Natural log both sides. So you get r is the natural log of 4.
1.38.
I'm going to leave it as natural log of 4. It's a nice looking number, dude. Okay, so then you take that and you go where with it? What was the question they asked?
Put it back into R.
Yeah, okay, so you plug that back into R. So now you know what your population model looks like, right? Your population model looks like 2e to the natural log of 4 times t.
1 times 1.
Times t. I used t as 1 to find out what r is, right? But in my model here, t is not 1, t is any particular time at all. So I could use this to figure out how many ferrets there are going to be in 17 years. What did they ask me to figure out? How many ferrets are there?
Make sure, write a model.
Oh, just write a model. Okay,
That's it.
so here's my model.
And that's it.
And then I need to, well,
Label some shit.
yeah, so I need to kind of think about labeling some stuff. So t is what? What was t?
Time
Time
in years.
measured in years. Okay, what else you got?
2 is the initial population.
2 is the initial population. I probably don't need to mention that.
Natural log of 4 is the rate.
Natural log of 4 is the growth rate. Okay, sure.
E is the exponential function.
E is the base of the E is the base of the natural log, or E is the natural
Log.
number, whatever
E the number.
thing. I don't think we have
E
it.
is the number.
It's really E is Euler's constant, but whatever.
Who cares?
T is the population.
And that's the one I really wanted. P of T is the number of ferrets at year T. That's really the thing I primarily wanted. It's cool with that? It's not that anything else you guys said was wrong, just what I want labeled is the variables that are still present in the problem, right? And there really are only 2. There's t, that's time in years, and there's p of t, which is the number of ferrets. Cool?
Thanks.
Yeah.